start. And yes, we are recording. And let's see if I can share my screen with you. And the screen share should be on. Is it on? Can you see the screen? Yep, fantastic. So all looks pretty good and straightforward. So it's the BI 308 Skills for Bioscientists module. Please don't forget to do your attendance. And I think in the chat has somebody posted the link? Yes, thank you very much, Conrad. That's excellent. We've got the link for the attendance monitoring. And I'm very grateful for that. And please do keep yourself muted because, as somebody said earlier, Clown Patrol is lethal. How are you guys actually doing in terms of revisions and things like that? You have another multiple choice quiz next week. Is that right? End of week 6. Yes, what I want to do with you is today I want to go a little bit more into detail about the practical measurements that you guys did. And because there were a few things that I was really glad people discovered in the practical. And I think we can do some really, really cool stuff with that, if you allow me to. And coming back to the MCQs, obviously there is BI 308. This module is not covered by the multiple choice quiz. We are going to have a test in I think it's in week 12 or something like that. And I will prepare some questions for you and also some kind of a cheat sheet. Please keep yourself muted. I can hear somebody. Well, that's a very, very good question, Luis, because this practical actually will be with us for quite some time. The experiment was really almost babyish, but there is lots and lots of stuff in there for theory. So, and the data that you've gathered will be used even if you didn't do the face-to-face, if you couldn't do that. And I know a lot of people did not gather the real life data, but there are some data available on the website, and we will go through the data. Some we will do today, and hello. Good. And some we will do, well, even next term, but we will use these data. So at the moment, I'm very pleased if people have their 15 measurements. So I think that's really important. And we will use these data in the following weeks and even months to do some data analysis with that. So, in terms of sort of giving people the opportunity to get some practice, I was wondering whether it would be worth next week, either Monday or Tuesday, to do a sort of Q&A session. So if people have any burning questions about a topic that I have covered, either in BI 300 or BI 308, although BI 308 is not part of the multiple choice quiz, but I was wondering whether people think that we need that. Do people think we need to have a sort of Q&A session? Well, the biomed engineering students didn't do the face-to-face practical, but you guys had the sort of the mock data on the website. So we will use these, or you can use these data for data analysis. And I really encourage you to look at the data. The only difference to the other students is that you didn't do the pipetting actually, but you will get these skills in other modules. And I see not a huge dissent in terms of people agreeing to Q&A session. If you could email me some kind of questions that you would like me to cover in this Q&A session, and I need to see when I am free. I think you all are pretty free on Monday and Tuesday. Is that correct? Because you don't have a practical class on Monday, Tuesday. Yeah? So I will see if I can schedule something for either Monday or Tuesday. And yeah, I fully go with that. I don't want a 9 a.m., so don't you worry about that. And it will be recorded, of course. So if you email me then questions where you think that would be useful for me to, go through or cover a little bit, then I will try and set up something over the next few days and send you the link. But please don't email me and say, I don't understand proteins. Because that's a little bit too general. The more specific you are, the better it is, the easier it is to cover. Okay, are you happy with that? Good. I'll see what I can do. Right. What I want to do with you today is I want to go through some of the things that I've discovered in the practical and that you have discovered in the practical as well. And to do so, I've got a data set here. And so it's this data set. Actually, this is a real live data set from a student who emailed me. And that student actually asked me a question about what to do with outliers. And I don't know how many people actually, when they did the practical, how many people got outliers? Charlotte got outlier? Louis got outlier? You got 2 outliers. Good Lord. So it's not uncommon. Hassan is asking actually an interesting question. So when people say they got outliers, what is an outlier? What is an outlier? How would you define an outlier? Mokam says he's got 0.26 if that is considered an outlier. A result significantly different from the majority of results. Yes, I would say this is a very good definition. We only need to then define what we mean by significantly, and we need a sort of a tool. More than 3 standard variations, we need to have a tool how we can identify what is an outlier. And there are a lot of really cool statistical packages out there that can calculate whether something is an outlier, but you really need to know what you're doing when working with these packages. But there is a very, almost a simple way. Shakil, I will come back to that because that is basically what we are going to do. There is a very simple approach to finding outliers. And this is by using a box and whisker plot. Box and whisker plot. And manipulating that a little bit and playing around. So what we need to do, so here are our data. And would you say that there is an outlier in there, in these data? Don't look at the other column. B1. So 0.324 grams looks like an outlier. But is it an outlier? Now, that is the big question. So you spotted it, but is it an outlier? So how do we find that? What we do in the first place is we need to be careful. We need to use the right tool that is sort of, in a way, helps us to identify an outlier. So this tool should not be affected really by outliers. So if we take the mean of the data here that we have, we might run into the risk that if we calculate the mean and there is a really bad outlier in it, it will hugely affect the mean. So we need to find something else that is not affected by the mean. Can you think of something that is not affected by the mean, but is still a measure of central tendency? And we did that in one of the sessions. What is not affected by the mean, by an outlier? Yes, it's the median, exactly. So what we do is, in the first place, we just simply sort the data that we have in this column here. We sort them by size. And we can do it either ascending or descending. It doesn't matter. I have done that here. So here, you can do that very easily in Excel or other programs. And so here we've sorted our data according to largest first, smallest at the bottom. And now we need to find the median of that. And if you've got not a big data set, you can do that easily by hand, or you can do that in Excel by finding the median. So let's find the median here. What do you think the median is of this data set here, of this sorted data set? You don't need to note it down, because it is recorded anyway, so you can have a look at it. But try to find the median of the data set. So let's see how we do that. Oh, there are lots of different views. Okay, so the median is the middle number. So the easiest way is I just do that. This, 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 this. From each end, I take things off to find the middle. Ah, look. This is the middle number here. This is the number in the middle. Okay, makes sense? This is our median. That's the median of the data set. Let me get rid of that. So that was our median. What we now can do is we have two additional data sets created. We have one data set here that is above the median and one that is below the median. And for each of them, we can again calculate. Well, I will ask you actually to find the median. When you do your data, when you look at the data, and you don't have to do it right now, but when you analyze your data, and I will ask you to analyze your data at the end of this session, I will ask you to find whether you had any outliers. So you would do that with your data then as well. So let's find the median of this data set, the above the median. What is the median of the top data set? Now, obviously, we need to make a decision, actually. Should we include this value here, this 403, as well in our calculations? Or should we not? Should we include that for the median or not? The 403. It says not, but with a question mark, so she's not entirely sure. Mariana said, I didn't. Did anyone think of doing it? Oh, Alessandro, you included the 403, right? So, depending on whether we include it or not, we might get a slightly different result. Now, here is the big thing. If you include this median that you just calculated from the whole data set, if you include that, you are right to include it. If you didn't include it in your data set, in calculating the median, you are right in not including it. There are at least 8 different ways of calculating these medians. So, and depending on who you listen to, some people will include it, others won't include it. I'm a bit of a traditionalist, and I treat data points like underpants, you use them only once. But there are other people who say, well, why not use them? And there is no firm convention in whether you should include it or not. It will lead to different results, but people have not decided whether they include it or not. Usually, if you have got large data sets, it doesn't matter. If you have got small data sets, then it does matter. Well, c'est la vie. That's how it works. So I usually don't include it. But Excel, if you use Excel to calculate what is called percentiles, it will include it. So be aware. So let's find the median of the upper data set. And this time we are not including, we are doing it my way, we are not including it. So let's strike off things again. And this would be the median of the upper data set. Well, for the you can then subdivide again this data set if you want, if you are inclined that way. And should you then include this median? Again, there's no firm rule. But this is the median for the upper data set. And let's quickly do that for the lower data set. So this would be the median for the lower data set. And we use the median because the medians are not sensitive to any extreme values. So what have we got? We've got our main median. We have got the median of the upper and the median of the lower data set. And we can calculate, so let's do a sort of a graphical representation of that. This is the median of the data, which was 0.403. This was the median of the upper data set, which was 0.406. And this was the median here of the lower data set, which was 0.400. Okay? No, you cannot mix and pick and mix the method. You have to be consistent. It doesn't matter which method you use, but you can't swap the method halfway around. That's quite important. I'm very glad that you asked this. So what we now can calculate is we can calculate the difference between the lowest and the highest median. So we can calculate this difference, which of course would be 0.006. You can include the median and be consistent with that, or you can exclude it, but always be consistent. This number here, this difference between this median, the upper median and the lower median, is actually called the interquartile range, and abbreviated as IQR. This is the interquartile range. So what have we got? Well, we actually have sort of our data. This here is the, and we split it, we chopped it into quarters, basically. So here, this part here is the first quarter. This part here is the second quarter. Here we've got the third quarter. And here we've got the fourth quarter. That is Jade's comment. It's a really it's a really good comment. And again, that is one of the 8 different versions that you can do in terms of calculation. So we've got the different quarters. And now, in order to find an outlier, there is a rule. So this is the first quartile that we have. Let me use a different color. So this is the first quartile, because this is the first quarter of our data. Then we have our second quarter, and so on and so forth. So we chopped our data sets into equal-sized 4 portions. Now, what we are now doing is the rule of thumb. We calculate, we take the IQR, the interquartile range, multiplied by 1.5. And there's a reason why it's 1.5, but I'm not telling you. So in our case, this would be, what's 0.006 times 1.5? That would be, help me out. IQR times 1.5. Do I need to get the calculator out? 0.009. So that's the, yep, that's right, 0.009. So that is this IQR times 1.5. And in order to find sort of the limits for outliers, what we do is we add this 1.5 times IQR to this part here and to this part here. So this is 1.5 times IQR. And this one here is also 1.5 times IQR. So here we would get 0.406 plus 0.009. That would give us 0.415. And here, this 1.5, that is just simply a value. You can derive it mathematically, but that is the rule of the thumb. And at the lower end, At the lower end, we would have 0.391. These are what is called the fences for outliers. Fences for outlier. So basically, anything that is below 0.391 and that is above 0.415 would be an outlier. So anything below 0.391 or above 0.415 is outlier. Does that make sense? This is an easy way to find outliers. All you do is you split your data into 4 equal things, into 4 different quartiles, like I showed you. You determine the IQR, that's from these 2 medians. You determine the IQR, you multiply it by 1.5, and then you either add it to the larger one or you subtract it from the lower one. Okay? Now, why is it called a box and whisker plot? Actually, what we have done, what we've determined is the outliers, but the correct representation for this box and whisker plot is we would, and I want this to, let me see if I've got this. How do I do that? Okay, never mind. So we had our box. This is the box. We had our median 0.406. Here we had 0.4, and here we had 0. No, that was 403, and here we had 0.4. So that's our IQR, interquartile range. And we know that anything below 0.391, that would be a fence, and 0.415, that's a fence. And now we go back to our data and we say, what is the last data point before we reach the fence? So what is the last data point before we reach the fence? For the upper one, it is 0.41. That's the last data point before we reach the fence here. So here we would have 0.41. That's the last data point before we reach the fence. And we would represent it like this. What is the last data point on the lower level before we reach the fence? What's the last data point on the lower level before we reached the fence. The fence was 0.391. From our data. What's the lower level? Before we reach the fence. So the fence was 0.391. What is the data point, the last data point, before we reach the fence? Absolutely right. That is the data point, the lowest data point before we reach the fence. So we would do that as 0.395. Does that make sense? This is the last data point before we hit the ceiling, before we reach the fence. So, but we have one additional data point. This is the 0.324. What do we do with that? Well, what we do is we indicate that in our plot with an X where it is located. And this actually, the 0.324, is a data point that is way outside the fence. And here's our fence. You can do it as a cross. You can do it as an X. Usually it is an X. Some people do it as a dot. And this here would be the representation of an outlier. This is a typical outlier. And it adds to the upper and it takes away from the lower. Absolutely right. So this is a typical, what is called box and whisker plot. Box because it has a nice box here. This box actually spans our data from this median to this median. It covers the second and the third quartile in this range here. How many data points are actually in this? How many of our data points are actually in this IQR? How many data points? 60%? 100%? How many of our data points are actually in this box? 2 out of 4, yeah? And in percent? %. 50% of our data are in the box. 25% are here. And 25% should be here, but actually we have an outlier. Does that make sense? So this is actually a very simple way where you don't need any sophisticated software packages. Because you can do it by hand. You don't need to do any complicated calculations. You just find the IQR, multiply it by 1.5, take it away from the lower, add it to the upper, and you get your fence. So this is how you find outliers. Now, the big question, of course, is what are you going to do with outliers? Outliers are like wasps, eh? Kill them. What shall we do with the outlier? You don't include them. Remove them. Banish them. I like that. This is an interesting expression. Go. Okay. So I assume this means do not include them in your calculations. Right. Now that's an interesting one. Erase them. I'll tell you a little story. And you will maybe think differently about it. Vote them out. Obviously, if it is an outlier where you say, right, this looks pretty much like an FFS, a fat finger slip, or I just wrote it down wrongly, or, with a pipette, I watched the pipette being leaking, or I observed some air bubbles, then I think it would be legit to eliminate the outlier. What if you've got two outliers? Again, if you feel that there is a problem and you can fully explain that problem, as I said, just a fat finger error or slip of the pen or something like that, then I think eliminate the outlier. However, the way I see it is that outliers are the motor of science. The motor of science, why do I say that? For example, in 1985, and by the way, you don't need all the details about the examples that I bring. No, the IQR was 0.006. Just in case you wonder. From here to here. That's the IQR, because there was a question. In 1985, scientists did a study on looking at the ozone levels in the atmosphere over cities. They were looking at ozone levels over big cities. And they did a lot of measurements. And they then said, oh, we need some unpolluted area where we don't have any interference with the ozone levels. And therefore, we measure the ozone levels over unspoiled area. And so somebody came up with the bright idea, let's measure the ozone levels over Antarctica. And guess what they found? What did they find over Antarctica in terms of ozone levels? They found that the ozone levels over Antarctica were extremely low. Now, had they said, well, this is an outlier from all our measurements, we just ignore it, we banish this outlier, well, life would be very different. But in true scientific manner, what they did actually, they said, wait a moment, there is something that is not right. This looks weird. This should not happen. I mean, we cannot explain that with things that, our measurements look reliable. Did anyone do something wrong with the program, with the analytics, with the data? Did somebody record it wrong? And they then said, well, this really warrants more investigation. So they did not just simply brush this outlier under the carpet. They actually reported the outlier so that other scientists could repeat the experiments. And lo and behold, they actually found that they get very similar measurements. They didn't get exactly the same measurements. Why did they not get the same measurements? Why did they not get the same measurements as the first group of scientists? Would you expect them to get exactly the same measurements? Outliers? No. Why not? Human error? No, not human error. Not the exact location. Or even if you had the exact location, what you do is when you do the measurements, you take a sample. Like you did with your tube A's. So you take one sample and then somebody else takes another sample. And a third group takes maybe a third sample. And because you take samples, each sample mean, of course, would be slightly different. Like you observed with your A tubes, B tubes, and C tubes. When you calculate the means of your measurements, you will find they are all in the same range, but they are slightly different. So there are always differences between the different sample means. And these differences are actually called, what are they called? Or what are they caused by? Starts with an S. What is the cause for these different sample means? And it goes into the central limit theorem, although we haven't discussed that. It's not the standard deviations. The differences between the sample means are caused by the standard error. Well, actually, I probably shouldn't call it standard error. It's caused by the sampling error. Whenever you deal with samples, you have sampling error. And this sampling error is expressed by the standard error of the mean and this sampling error, we know how we can calculate that. That would be the sample standard deviation divided by the square root of n. So that would be our standard error of the mean, which is a representation of the sampling error. And what we can do now, of course, is we can calculate this sampling error. All we need to do is we need to calculate the standard deviation for the sample and divide it by the square root of the number of observations. And this is again something that we obviously need to do, and that's something for another time, I would say. Any burning questions? And the question was, what do we do with the outlier? Well, my suggestion is keep it in. It might tell us something. Keep it in. It is honest to keep it in. My approach is keep outliers unless they are totally obvious that I wrote something down wrong. But if they are not immediately obvious, keep them in. This is honest. This is proper science. Well, if you can, for example, if you've got something really obvious, then you just simply indicate that and say, right, this value, I watched this value here, this 0.324, I saw that something happened. So what you can say is one value was removed for technical or because the pipette was faulty. So I would suggest keep 0.324 in your analysis because it is an outlier as we determined, but there's no immediate obvious reason why you made this measurement. And please, Hamza is absolutely right. Please don't forget your attendance. I think it's open for another 2 minutes. So thank you very much. I hope you learned how to determine outliers. And in tomorrow's session, I haven't decided what we are going to do. So let's see what I come up with, whether we continue with that or you are currently doing a virtual practical in BI 300 on sugars, don't you? Are you doing a practical in BI 300, the sugars, before you bug off? Honey, yeah. I wonder, do you have to do a full-blown write-up for that? Or have you started with it? Okay, you haven't covered it. Okay, good. Then tomorrow I will we'll do a little bit more on reporting data. And then next week, I show you what will happen if we don't take just measurements in one dimension, but we do it in 2 dimensions. Okay, good. I know what we are going to do. So in this case, have a lovely day. I see you tomorrow and enjoy the rest of your day. And thank you very much for watching and for your contributions. And I will see if I can sort something out with a Q&A session next Monday or Tuesday. But please email me questions that you want me to cover. Okay? See you later. Be good. Don't do anything I wouldn't do.